Okay, now for our last example of solving inequalities, we have the situation where it says negative 6 is less than or equal to 2x plus 4, which is in turn less than or equal to 12. So the way we handle these is basically, again, the objective is to be able to solve the inequality for x. So we want to be able to get x by itself. That means we need to get rid of our 4 and we need to get rid of our 2. So the only difference is that because we have now what we call this compound inequality, when we get ready to subtract 4, well, we want to subtract 4 everywhere on all sides of our inequality. So negative 6 minus 4 signs are the same, so we add and keep that sign. This is less than or equal to 2x, which is less than or equal to 8. Last move, this is multiplication, 2 times x. So the way we rid ourselves of our 2 is that we divide everywhere by 2. Now had this been a negative number, again, the inequality symbols would have changed. So negative 10 divided by 2 is negative 5, which is less than or equal to x because our 2's cancel out, and this is less than or equal to 4. So as we get ready to graph now, because we have two numbers that are that is involved in our inequality, we put both of them on the number line, negative 5 and we put 4. Now, just to give a brief explanation about what these solutions are saying, in order any number for x that will make this be a true solution, this situation says that any number between negative 5 and 4 will actually be a solution to this inequality. So it's not that negative 5 and 4 are our only two solutions. That's the power of inequalities. The solutions here are all lie within negative 5 and 4. Not only do they lie between negative 5 and 4, here the situation calls for us to actually include negative 5 and 4. So instead of us having open circles, we would actually have closed circles at those numbers. Closed circles at those numbers. Because it says x is greater than or equal to negative 5. X is less than or equal. And so we would actually shade in between. And the reason for that is because when you read your inequality, when you read x is greater than, see now you have to read from right to left, x is greater than or equal to negative 5. So all numbers that are greater than negative 5 will be found to the right of negative 5. But also it includes, it says those solutions x that are less than or equal to 4, those solutions that are less than 4 will fall to the left. So if you can imagine here, if we were to draw an arrow to the right of 5 and to the left of 4, then the solutions would actually overlap in the middle. That's why this is a compound inequality. We're not considered with those solutions that protrude outside here because it doesn't satisfy both situations. See, any solution here has to satisfy both situations, meaning the number has to be greater than or equal to negative 5, and it has to be less than or equal to 4. So even though it says x is greater than 5, and we know that our line goes all the way to the right, well, give me a number that's greater than 4, say 10. Well, yes, it's greater than negative 5, but 10 does not satisfy. I couldn't stick 10 here and it satisfy both situations. Let's see. Well, if I put a 10 right here, 10 is greater than or equal to negative 5, but 10 is not less than or equal to 4. So that's why we don't bother with those solutions that extend beyond negative 5 and 4. Only those solutions that fall in between or those two will actually be solutions to this situation.